Hi, thanks for joining me today. I've got a nice short video for you. We're going to be proving that the Earth is tiny. So here I have a picture of the Earth like so, and what I'm going to do is I'm going to walk around the circumference of the Earth like so, carrying a piece of rope. So I tie a piece of rope that goes all the way around just like this. It's just touching the circumference of the Earth like so. So what is the length of this rope, L? Well, it's just going to be 2 times pi times capital R, where R is just the radius of the Earth. And it turns out that R is something like 6,371 kilometers, so 6,371,000 meters. Now what we're going to do is we're going to take this rope and we're going to snip it, say here. So now we have one long piece of rope which has length L. Now what we're going to do is consider a rope of length L prime, and what it's going to be is L plus 1. So it's going to be this really long rope, which is 6,371,000 meters. So yes, 6,371,000 meters long, and then I'm going to add on 1 meter, like so. So it's the length of L plus 1, so ever so slightly bigger than L. And what I'm going to do is I'm now going to take this new rope, L prime, and wrap it around the Earth like so. So of course it's just going to be slightly in the air. So I'm going to make it a perfect circle around the world, and then there's a small distance here. And now in our heads, this distance here intuitively should be tiny. It should be minuscule. We've only taken L and we've increased it by 1 meter. So this distance here should be tiny because we know the Earth is huge. It has radius 6 million meters, so adding 1 meter to this new rope shouldn't really increase the height by much at all. It should be fractions of a millimeter, if anything. However, let's work this out. Let's look at this new radius, which I'll call r prime. And so what is r prime? Well, we know that 2 times pi times r prime is equal to L prime, which is just L plus 1. So if I divide both sides by 2 pi, I get that r prime is equal to L plus 1 over 2 pi. And so this small distance here is just going to be r prime minus r. So the distance d is r prime minus r, which is L plus 1 over 2 pi minus L over 2 pi. But the L over 2 pi's cancel, and all we're left with is 1 over 2 pi. But this doesn't seem right, because 1 over 2 pi meters is still pretty big, right? That's, approximately a sixth of a meter, and that's not a fraction of a millimeter. So, can you spot the mistake?